So here we are, we're still working on problem 3 on the practice exam, and we've done parts A and B, and now we are going to start with C and do C and D. Find the intervals of concavity and the inflection points. So how in God's green earth can we figure that out? We know that concavity has to do with the second derivative, right? Concavity. So the rule is that f is concave up on AB if the second derivative is positive on AB. Okay. And f is concave down on AB if the second derivative is negative on AB. Then when we have nice smooth functions like this one, which is defined everywhere and continuous and differentiable as many times as you want, these are actually, if and only ifs. Alright, and so that's what we're going to use to solve this problem. We already have the first derivative, so we should use this to make it easier for us to compute the second derivative. Right, so if we have f prime of t, what is f double prime going to be? So let's write this down. So f prime of t we just found to be 1 minus sine t, and so this means that f double prime of t is going to be equal to just negative cosine of t. Okay, and so remember we're doing everything on this interval from negative 2 pi to positive 2 pi. So what we're interested in is where on this interval negative 2 pi to 2 pi is cosine t positive and where is it negative? So that's going to answer all of our questions about concavity. So let's see. Okay, so you know a lot about cosine t. You've been studying it for a while, and you could probably do this pretty easily. But okay, so how are we going to do this? So let's set it equal to 0. So let's do negative cosine t equals 0. Okay, so first we'll find its roots, and so where is it going to be true that cosine, which remember is the x-coordinate, where is it going to be true that cosine is 0? Well, cosine likes to be 0 here at pi over 2, and it also likes to be 0 here at 3 pi over 2, because, the axes are secretly here, and so that is where the x-coordinate is 0, and so those are the solutions here. Okay, so we have t equals pi over 2, and also t equals 3 pi over 2. Okay, so that stuff that we just did is from the point of view of going around the circle like this. Okay, but we also have to consider these negative values that are in this interval that we're interested in. So that's like spinning around the circle backwards. Okay, so what if we spin around the circle the other direction? Maybe I can erase these green things by pressing Control Z. Alright, so let's say that we spin around like this. Okay, so cosine is still going to be 0 here, but now since we're spinning to the left, we're going to call that minus pi over 2. Okay, and we're going to call this one, it's going to be 0 again here, but since we're spinning clockwise, we're going to call this one minus 3 pi over 2. Alright, so we found, and these are all the solutions. Okay, we've done one full circle forward and one full circle backwards, and those are the only places where cosine is 0. So here are our solutions. I hope you can see this weird color. Okay. Alright. So what do we need? We need to know, now we have the line. Alright, so let's call, I'm going to switch to red. I'm not confident that you could see that weird brown color. So this is 2 pi, and here is negative 2 pi. Alright, and let's put these things in here. Alright, so here's 0, so here let's say is pi over 2, and here is negative pi over 2. Okay, and here is minus 3 pi over 2, and here is positive 3 pi over 2. And what we want to do is we want to know the sign of negative cosine on each of these parts. Okay, so we could plug in values, and we'd have to plug in 1, 2, 3, 4, 5 values. It's just too tedious for me to possibly consider doing. I'm sorry. So how else can we figure this out? Well, we could reason by looking at the circle here. Okay, so let's imagine. Is that going to be confusing for you? Let's assume that it is. Okay, so maybe the easiest thing to do would just be to graph negative cosine. Right, so normally cosine starts up here, but now this is negative cosine, so everything is reversed. So it goes like this, and this will be 2 pi, one full period forward. And now let's look at one full period backwards. So one full period backwards at minus 2 pi. Okay, so this makes it much easier, right? So you can see that on this first part we have negative, right? And so on this next part the function negative cosine is positive. Whoops, don't know why I did that. Positive, and then it's negative again for this part, and then positive and negative. And so now we know everything about the concavity, right? So the original function is going to be concave up on this part, concave down on this part, concave up on this next part, then concave down, then concave up, then concave down. Okay, so let's write that stuff down. Okay, so f of t is cup up, or concave up, on the intervals, just the intervals where the second derivative is positive. So negative 3 pi over 2 to negative pi over 2 is one of them. And then the other one is, for the second plus sign, it's pi over 2 to 3 pi over 2. Okay, alright. And alright, so we also know that on the other places it's going to be concave down. So it's concave down on, so I'm just going to, I'm going to write the complement of what I have there. So negative 2 pi to negative 3 pi over 2. And then again from negative pi over 2 to pi over 2. And then again from 3 pi over 2 to 2 pi. Okay, great. And alright, so one final thing I think is we should give the inflection points. Okay, so let me remind you what an inflection point is. So f of t has an inflection point you can take this as the definition at each t at which f double prime of t changes sign. Okay, alright. So there are lots of those, right? So we have quite a few here. So these are our inflection points. They are minus 3 pi over 2. They're basically all the roots of the second derivative. Minus pi over 2, pi over 2, and 3 pi over 2. Okay, so these are our inflection points. And I had to write that in the answer spot for D. I'm sorry. Let's go up and see what D is. And it says, use the information from these other parts to sketch the graph. That's such a horrible request to make on a person